Hello guys, today I will show you how we can evaluate magnetic force in a planar actuator. So here is the brief description. So we have almost 25 centimeter by 25 height dimension. So I assume that you know how we can create geometry in the electronic desktop, or we can import the drawings. So here you can see we have, this is the surrounding air medium, or you can say this is the core. We have, this is the plunger, and these are coils. So this is a cross section view of a planar actuator. So this is, these two are made of steel, and this is basically we have to solve magnetic field in the air also exists. So this is the surrounding medium, and these two are coil. So we have to evaluate force on this plunger. So we'll select it, then we'll go to assign parameter and go to force and select OK. So it will appear here. Now we have to assign currents here. So we'll select both the coils and we'll assign current. So this is in ampere. So 1300 are the turns and 2.5 is the current. So we'll multiply it, because the total current, if you see here, it will be 1300 into 2.5. So this is the total current flowing through this cross section area. So we'll select, one of the coil is carrying current in the opposite direction, so we'll change current in the one coil. Then the next part is we have to assign boundary conditions. So we'll select all the edges of outer boundary, go to boundary. Either you can put a balloon boundary condition, or you can go to the vector potential and put equal to 0. It means we are forcing flux is parallel to these boundaries. Then you'll go to the analysis, add solution, and we'll make one it, and you have to set design setting depth 10 centimeter. We have to make depth is also, because in our problem we are considering 10 centimeter depth. Now we can run it, analyze. So the air gap here is 2.5 centimeter, and if I roughly evaluate force on the plunger, it is around 106 Newton. And in FEA it will be slightly lower, because we will consider some magnetic MMF required for the steel part as well. Means there will be some reluctance offered by this steel as well. So now solution is done. We can click here and see the results. So it is around 96.5 Newton. So that's in line with our analytical calculation. If you want to see how the flux setup, so you can go flux line, plot flux lines. So you can see these flux lines. We have selected odd line, that's why it's coming like this, because it's completely symmetrical. Now you can hide, you can see the fringing effect clearly visible. And now if you want to see the flux plot as flux density, you can go flux density, plot it. So you can change the scale here, you can go make it Tesla, so it's very low. So this is how we can solve this problem here. Now if you want to define a coil, you can just copy it and delete these two terminal, select these two and give coil as a terminal. So total 1300 are turns, and give one coil as a negative direction of current. Now you have to select add winding here. You can make a strand current is 2.5, and then you have to assign add these coils here. Select both. Okay. Now if you change current here simply and run it. So we can run it again. Now we can see the solution. It will be same. It should be same. Let's see. 96 same results. So that's how you can solve actuator problem in electronic desktops. There is a normally we evaluate holding force. Holding force means this plunger is touching to the stationary part. Then that time we evaluate holding force. In that case we have to take care of surface roughness. If surface is not properly finished, then we have to keep some air gap to consider the surface roughness. If surface is very highly finished, then we can keep the minimum air gap, because holding force is inversely proportional to the square of air gap. So you will see curvature like this, and here your G and force. So a small air gap will change your holding force drastically. So surface roughness play very crucial role in the holding force values. You will see sometime 30-40% change in the holding force itself. So we have to take care while we are evaluating holding force through FEA, and we need to know what is the surface roughness level. Thank you.